So the key thing to understand here is that when you ingest alcohol, you are, yes, ingesting a poison, and that poison is converted into an even worse poison in your body. And some percentage of that worse poison is converted into a form of calories that you can use to generate energy, generate ATP. And the reason why alcohol is considered empty calories is because that entire process is very metabolically costly, but there's no real nutritive value of the calories that it creates. You can use it for immediate energy, but it can't be stored in any kind of meaningful or beneficial way. It doesn't provide any vitamins. It doesn't provide any amino acids. It doesn't provide any fatty acids. It's truly empty calories. I know some people talk about sugar as empty calories, but sugar actually is a far better fuel source than alcohol or acetate. But nonetheless, when you ingest alcohol, some percentage is being shuttled into a worse poison and some is being shuttled into a fuel source. Now, the important thing to understand is that it is the poison, the acetaldehyde itself, that leads to the effect of being inebriated or drunk. I think most people don't realize that being drunk is actually a poison-induced disruption in the way that your neural circuits work. And so we should ask ourselves, like, which neural circuits, what brain areas, what body areas involved in feeling drunk or inebriated? In thinking about the biochemical effects of alcohol and what it's doing to the body, what it's doing in all cases is it's consumed into the gut, right? Goes into the stomach. The liver immediately starts this conversion that we talked about before of ethanol to acetaldehyde to acetate. And some amount of acetaldehyde and acetate are making it into the brain. It crosses the blood-brain barrier. Again, the brain has this fence around it that we call the blood-brain barrier, or the BBB. Many things, most things, thankfully, can't pass across the blood-brain barrier, but alcohol, because it's water and fat soluble, just cruises right across this fence and into the milieu, the environment of the brain, which is made up of a couple different major cell types, neurons, nerve cells, and so-called glial cells, which are in between the nerve cells. And we'll talk about the effects on each of those soon. So what happens when alcohol gets into the brain that makes us feel tipsy or drunk, and in some people makes people feel really especially energized and happy? Well, alcohol is indiscriminate in terms of which brain areas it goes to. Again, it doesn't bind to particular receptors, but it does seem to have a propensity or an affinity for particular brain areas that are involved in certain kinds of thinking and behavior. So one of the first things that happens is that there's a slight, at least after the first drink or second drink, there's a slight suppression in the activity of neurons in the prefrontal cortex. This is an area of your neocortex that's involved in thinking and planning, and perhaps above all, in suppression of impulsive behavior. So if you go to a party and they're serving alcohol and people are consuming drinks, what you'll notice is that a few minutes into that party, the volume of people's voices will increase. And that's because people are simply not paying attention to their voice modulation. As other people start speaking more loudly, other people are speaking more loudly. We've all had this experience, right, of going to a party and then you step outside for a moment and you go, oh my goodness, or shouting. You come home the next day, you got a sore throat. It might be that you picked up some sort of bug, some virus or something. But oftentimes it's just the fact that you've been shouting all night just to be heard, because as the prefrontal cortex shuts down, people stop modulating their level of speech quite as much. Also notice that people start gesticulating more. People will start standing up and sitting down more. They'll start walking around more. If there's music on, people might spontaneously start dancing. All of this is because these areas of the prefrontal cortex normally are providing what's called top-down inhibition. They are releasing a neurotransmitter called GABA onto various parts of the brain that are involved in impulsive motor behavior and thought patterns. And as you shut down the prefrontal cortex, that GABAergic suppression of impulses starts to be released. So people will say things that they want to say without so much forethought about what they're saying. Or they might do things that they want to do without really thinking it through quite as much, or they might not even remember thinking it through at all, or experience, I should say, thinking it through at all. We haven't talked about blacking out yet and the effects of alcohol on memory. But as long as we're there, I'll just tell you that alcohol has a very strong effect in suppressing the neural networks that are involved in memory formation and storage. This is why oftentimes we forget the events of a night out if we've been drinking. One of the more important things to know about the effects of alcohol in the brain is this disruption in top-down inhibition, but also that areas of the brain that are involved in flexible behavior, sort of considering different options. Like I could do A or I could do B. I could say this to them or I could say that. I could say it in that way or I could say it in this way. This might be a little more tactful. Those brain areas basically shut down entirely, and people just tend to say what they want to say. So the key thing to understand is that when people drink, the prefrontal cortex and top-down inhibition is diminished. That is, habitual behavior and impulsive behavior starts to increase. Now, what's interesting is this is true in the short term, so after people have 1 or 2, maybe 3 or 4 drinks, but it's also true that the more often that people drink, there are changes in the very circuits that underlie habitual and impulsive behavior.